Hello, my name is Leo. Today we're going to talk about addition of forces acting on a rigid body. So first, what is addition of forces? Addition of forces is method of summing all force vectors one to the other. So as to get a net force, which is a resultant force, so sum of all force vectors. There are four basic systems of forces: concurrent, parallel, antiparallel, and coupled force system. So first is concurrent force system, where we have two or more forces, for example forces F1 and F2, whose directions intersect, so they are not parallel. For P1 and P2 are points of force application. So first we have to construct directions of these vectors. Now we get their intersection. And now we translate these two force vectors so to have the tail in this intersection. Now we have to sum that two vectors by some method of addition of vectors. For example, here is presented parallelogram method. And now this resultant force is translated so that its point of force application is on line segment which connects P1 and P2. And here is F, that resultant force we've got. So these two forces, F1 and F2, and the resultant force F. Parallel forces are those forces which are actually collinear vectors, so have the same directions, so they don't intersect. Here we have again F1 and F2. First step is to construct a straight line which goes through P1 and P2, so forces of their application. Now we have to add a vector phi0 on F1 and minus phi0, which is opposite of phi0 vector, to F2, and that can be that is an arbitrary vector. Now we sum vectors F1 and F0 to get F1 apostrophe, and F2 and minus F0 to get F2 apostrophe. Now we construct their directions, and where they intersect, the next steps are similar to the concurrent forces system. Now we translate these two forces F1 apostrophe and F2 apostrophe so to have the same tails in their directions intersection. Now we sum them up by parallelogram method, for example, and now we translate that resultant force so to have the tail at the line segment connecting P1 and P2. And here is P, which is point of application of force application for resultant force F. Now antiparallel forces are actually parallel forces, so they are collinear, but have the opposite orientation. For example, F1 and F2. The first steps are dissimilar as for parallel forces. So we sum F0 and minus F0 to F1 and F2 respectively. Find the resultant vectors F1 apostrophe and F2 apostrophe. Construct their directions, find their intersection, translate them so to have the same tail, sum them up to the vector F apostrophe, and now that vector F apostrophe we need to translate so that its tail is intersection of these two straight lines. This straight line is actually direction of force F0 and minus F0, also a straight line where P1 and P2 lie on, and of this second straight line, which is actually direction of F apostrophe. And now we get this red force resultant vector F with this P as a point of force application. And finally, force couple is a system of antiparallel forces which have the same length. It's important to say that in force couple system also called pure moment or coupled system, we cannot find net resultant force, but we can find resultant moment, which is called torque, and has a special property that it doesn't depend on a point of force application. Also, it's very important then that a body in force-coupled system does not translate, it only rotates, and its center of mass doesn't accelerate. Thanks for watching. I hope you've enjoyed this video and that you've learned how to add forces one to the other as forces acting on a rigid body. And stay with us.